Of all the features listed on the product comparison chart, there are really two key differentiating factors: networked audio capability and DSP. Regarding networked audio, some devices only have BlueLink, and some devices have BlueLink plus one other Ethernet-based audio transport, namely Cobranet, AVB, or Dante. There are also two devices which only support Cobranet and one device which has no networked audio capability whatsoever. But please note that these models, the Blue 80, Blue 32, and Blue 16, are discontinued. Regarding DSP, some have it and some don't. In the software, if you go into a DSP-enabled device, let's just use a Blue 160 as an example, you'll be able to right-click and add processing objects. As mentioned previously, these let you manipulate audio signals. And to demonstrate how you might use these processing objects within a design, let's just quickly go through a real-world example. Let's say you have a system consisting of 12 mics which need to be processed and then sent to 4 mono zones. To keep it simple, let's just say each zone contains a single powered loudspeaker. So you need a Soundweb London system consisting of 12 analog inputs and 4 analog outputs, or 12 by 4 for short. A Blue 160 could be used to accomplish this. You'll need it to have 12 analog inputs, so it needs to have 3 analog input cards. And you'll need it to have 4 analog outputs, so it needs to have 1 analog output card. So let's process each one of these mics with a high-pass filter, a noise gate, a compressor, and an EQ. And let's run those processed mics into a matrix mixer. With 4 outputs, which gives me 4 mixes. And let's give each zone its own dedicated EQ. And limiter. And then I would just need to decide on the controllers I want, and that's it. I'm off and running. Some devices have more DSP than others. For example, the Blue 160 has 800 MHz of DSP power, while the Blue 100 has only 400 MHz. That means you can drop twice as many processing objects within a Blue 160 as you could within a Blue 100. And if you ever wonder how close you are to maxing out the DSP within a device, it's actually very easy. The DSP Resource Usage Meter gives you the answer. Watch what happens as I add processing objects to a Blue 160. It's telling me that 4 stereo 12-band EQs are consuming 8% of the Blue 160's DSP. Therefore, this same design within a Blue 100 will consume 16% of the Blue 100's DSP. Notice that I never had to manually hit any button that says compile. Our software automatically does that for you as you build the design, which is nice because you always know exactly where you stand. Another nice thing is that we make it pretty simple for you. As long as it's not above 100%, the design is guaranteed to work on that device, period. If it is greater than 100%, then the DSP meter will turn red, and the software will prevent you from loading anything to that physical device until you bring it back to 100% or less. For devices without DSP, let's use a Blue 120 as an example. You'll find that if you go inside them and right-click, you will not be able to add any processing objects. All you can do is draw wires. AV professionals commonly refer to non-DSP devices using different generic names, including break-in, break-out boxes, or on-off ramps, or input-output expanders. But regardless of the name, it's all the same concept. Their purpose is simply to add local inputs and outputs to a system. So, real-world example. Let's say you have a system consisting of 20 mics and 12 mono zones. Alright, so you're going to need a 20 by 12 Soundweb London system. To achieve this, you could order 5 analog input cards, this gives you the 20 inputs, and 3 analog output cards, this gives you the 12 outputs. Now, in order to choose the appropriate devices for all those cards, you basically just need to decide which audio transport you want. Generally speaking, unless one of the 3 Ethernet-based transports is specifically required, it's a popular choice to use BlueLink only because BlueLink is extremely powerful while being simple and therefore reliable, and also because BlueLink only devices cost the least, i.e. you'll save money. So let's just say you decide to use BlueLink only, which means you could order a Blue 120 and a Blue 160. It's almost irrelevant which cards you install into which chassis. The biggest determining factor is really the physical locations of the mics and speakers. But let's just say you decide to install 2 analog input cards and 2 analog output cards into the Blue 160, therefore making it an 8x8 analog I/O device. And you install the other 3 analog input cards and the other 1 analog output card into the Blue 120, making it a 12x4 device. And there you have it. There's your 20x12 system. The 12 mics on the Blue 120 travel across BlueLink on Cat5 E-cable to the Blue 160, where they can be processed alongside the other 8 mics. And 8 of the 12 mixes directly exit the analog outputs in the Blue 160, while the other 4 first travel across BlueLink before exiting the output card in the Blue 120. And remember, BlueLink is ultra-low latency. Each hop takes well under 1 millisecond. So you certainly don't need to worry about BlueLink ever causing unmanageable or really even noticeable latency.